So we are going to be looking at the classification of proteins based on organizational structure. Based on organizational structure. We know at this point that the building block of protein is what? Amino acids, right? Now, based on organizational structure, we can classify proteins into, based on their structure, into one, primary structure of protein. Now, the primary structure, if you don't use primary structure, you can say basic structure, the fundamental structure. So the basic or fundamental structure of protein consists of only the amino acid sequence. Are we following? Already in the previous heading, we said that if the protein contains only amino acid, what do you call that protein? Simple protein, right? Now, if we are looking at the amino acid sequence of the protein, that amino acid sequence of the protein is what? Primary structure. This is what I mean. If I have one amino acid like this, one, two, three, four. Is this a dipeptide or a tripeptide? Is this a dipeptide or a tripeptide? Is it what? It's a tetrapeptide. It's having 4 amino acids now. So it's a tetrapeptide, right? Now, if you look at this amino acid, this is what? A is what? This is alanine. This is lysine. This is tryptophan. This is thyroxine. These are their 1-letter codes, but don't bother yourself. Now, alanine, lysine, tryptophan, thyroxine. The way they are linked together, if I have something like this, if this is the first protein and this is the second protein, are they the same thing? Is this protein same as this? If you notice, they have the same amino acids, right? But they are linked together differently. The amino acids are linked together differently. Now, the way the amino acids are linked together is called the amino acid sequence. Now, the amino acid sequence of protein consists of the what? The primary structure. So if they give you protein and they said, what's the primary structure? They're asking you, how are the amino acids linked together? So you will not be telling them, okay, alanine is linked to glycine, it's linked to tryptophan, it's linked to. So the primary structure, you are now asking you, back to this our building, this class. Remember, we all agreed that this class, this building, this class is the macromolecule, right? Now, and the building block is the block they use, the brick they use, is it not? If they're asking you the primary structure of this building, the primary structure is the way the blocks are linked together. Do we understand? The way the blocks are linked together is the primary structure of this building. So, the way the amino acids are linked together, the amino acid sequence consists of the what? The primary structure of this. Do we understand that? Now, the secondary structure of protein, we are now looking at interactions between the amino acids. All right, now let me do something now. Is the structure of amino acid always just straight chain? Most times. There are some levels of folding, right? Now, in secondary structure, we are now looking at not the linear structure of amino acid now, but now folding of the amino acids. Remember that we said if the protein contains one polypeptide chain, that protein is called what? I treated that last time. If a protein contains just one polypeptide chain, you call it what? Monomeric protein, right? If it contains 2 or more polypeptide chain, you call it what? Multimeric protein. Good. Now, if I have something like this as protein, this monomeric, right? If I have something like this, 2 of them, 2 polypeptide chain, that's what? Multimeric. Good. Now, secondary structure, we are not looking at the linear amino acid chain. We are not looking at intramolecular interactions, inter and intramolecular interactions that leads to folding. So if the amino acid sequence is just like this, interactions that can make it to fold, maybe this way, make it to fold, gives us the secondary structure. Do you understand? The secondary structure, that folding of the primary structure, folding of the primary structure gives us the secondary structure, right? Now, the secondary structure can either be an alpha helix or the beta pleated sheet. This alpha helix and beta pleated sheet is just the way they are folding. In the alpha helix, we have something like this. I want to clean this. Now, the structure on the board is what? It's a dipeptide, right? Because I link one amino acid with another amino acid. Please, I treated it this last class and I'll drop the link. So this is one amino acid to another amino acid. In alpha helix is a right-handed helix that looks like this. I'm not drawing it where. I'm not drawing that way. Okay, let's manage this one. Now, you can see it's not linear again. The linear structure is the primary structure. But this folding gives us the what? The secondary structure, right? Alpha helix results from the interaction between oxygen on the carboxylic acid group of one molecule of one polypeptide. This oxygen here, let me bring it down. And the hydrogen of the amino group from another polypeptide. Let me explain what that means. This is one polypeptide chain. Let's assume if I have another polypeptide chain here like this, if I have, this is one polypeptide chain and this is another polypeptide chain. Alpha helix is formed when this oxygen here, hydrogen bond is formed between this high oxygen here and hydrogen on the amino group of the next molecule of another polypeptide. Let me take that again. Alpha helix is formed when hydrogen bond is formed between oxygen on the carboxylic acid group of one polypeptide is linked to the hydrogen on the amino group of another polypeptide that is 4 residues away. Now let me explain what that means. If a bond, remember this thing like this is straight, right? In fact, let me use just one molecule. Let me use just one polypeptide because it can happen between just one polypeptide or between both. If we have one long polypeptide like this thing continues. If this hydrogen here, if the oxygen, let me add another one here. And it continues. If this oxygen forms a hydrogen bond between this hydrogen, if there's a bond between this oxygen here and this hydrogen here, what do you think will happen to this chain? It will bend, right? It will bend. So that is how alpha helix is formed. Hydrogen bond is formed between oxygen on the carboxylic acid group and hydrogen on the amino group. So this bonding will now result to a folding, right? But now this bond is formed between oxygen on carboxylic acid and hydrogen for after 4 residues. So after 4 amino acid residues, these bonds are formed. So you see, if hydrogen bond is formed here and here, this side will fold, right? We go on, something like that is formed again. We go on, something like that is formed again. So you see that there will be a level of folding. I don't know if you understand that. Now, that is how alpha helix is formed. If you look at it, it's organized. But beta pleated sheets, Beta pleated sheet is a zigzag structure. This is 1, right? This is 2, right? The next one would have been 3. Just like we have dipeptide, tripeptide, right? Like that. So if this is 1, this is 1 amino acid. 2, 3. The fourth one, that is where the hydrogen bond will form. No. It's 4. Yes. So it's a regular pattern like that. After 4 residues, like that. That's when the bonding occurs. But beta pleated sheet is a zigzag structure formed. So if you see the structure is just zigzag, no regular pattern. But alpha helix is a regular pattern formed. But one thing you should understand is what is causing this the formation of this secondary structure is hydrogen bonding. Do you understand? Primary structure is linear structure of amino acids, right? If the amino acid is fold, if there is hydrogen bonding that leads to folding of the primary structure, what do we have? And we say the type of folding, if it is regular, alpha helix. If it is zigzag, beta pleated sheet. Basically, that's what I've said so far. That's what I've said. But now we've gotten folding. With the interaction have led us to have something like this, folding. But this thing can still fold, right? Folding of the secondary structure. Further folding of the secondary structure to give us a 3-dimensional structure is called the what? Tertiary structure of protein. So the tertiary structure of protein is the 3-dimensional structure. Do you understand? Secondary structure is just folding of the primary structure. It's not well folded. It's just then further folding of that secondary structure so will give us the what? Tertiary structure. So the tertiary structure is the 3-dimensional structure of protein. That's the exam question. Dash. Have they given you the past question? Are you with it? The past question. Alright, so further folding of the secondary structure will give us the tertiary structure. Are we okay with that? Yes. Where is what? This one. Where is it coming from? Okay, so thank you for that. Supposed to be like this, right? Thank you for that. So this is the peptide bond. Please take note. This is a peptide bond. There's no oxygen in between because condensation reaction. I thought that's like last class. All right. So in quaternary structure, we said quaternary structure of protein consists of different polypeptide chains, right? If I have one polypeptide chain already folded, I have another polypeptide chain already folded, and these two bonds together. This chain is different from this one. Oh, this one already has its 3-dimensional structure. This one has its own 3-dimensional structure, and there's an interaction. There's a bond between these 2 or 3 or 4. That will give us what? Quaternary structure of protein. So quaternary proteins have 2 or more polypeptides in their 3-dimensional states joined together, and they work as a single molecule. If you understand that, I will know with this question. Can proteins that have, some proteins can have one polypeptide chain, right? Those proteins that have just one polypeptide chain are called what? Monomeric proteins, right? Can monomeric proteins have quaternary structure? They cannot, right? Monomeric proteins have only one polypeptide chain. But now we are saying quaternary structure is interaction between 2 or more polypeptide chain. So if the protein has just one, it cannot have quaternary structure. But if it has 2, then these 2 can interact to form a single unit, right? Quaternary structure. So what I've said so far, the amino acid sequence of the protein gives us the what? The amino acid sequence gives us the structure. Primary structure, right? if there is hydrogen bonding between oxygen and hydrogen in that primary structure leading to a folded structure, that will give us what? Secondary structure. And we said which one is zigzag in the secondary structure? Beta plated sheet, right? Good. And we said further folding of the secondary structure to give us a three-dimensional structure will give us what? Tertiary structure. Then we said if we have two or more polypeptide chains interacting together to give us a single unit, that will give us what? Quaternary structure.